Hi everyone. The other day when I was sorting through some of my old test equipment, I came across this little item, which is a 3.5 digit digital multimeter, which I purchased way back in 1979 at my local Tandy store for the princely sum of £34, which was a considerable amount of money in those days when you consider that you could buy an analog meter for the hobbyist for around £5. The meter itself was branded under the Radio Shack name, Micronta, but it was in fact manufactured by Sinclair Radionics in Cambridge in England. Sinclair themselves marketed this product under their own brand name, Sinclair, and they gave it the model number PDM35, and they sold it for the same price. So what we're going to do today is have a look at this, see whether it still works, check the accuracy, and then take it apart and just see how they put that together. So let's have a closer look. Well, here we have a closer look at the meter. Just have a look at the on-off switch. There is at the top at the side, and you also have a small jack socket there for a mains adapter if you want to use it without the battery. As you can see on the meter, we have a switch there at the top which is going between ohms and volts and current ranges, and the range switch is simply a slider switch here, and it goes up by multiples of 10. The input sockets are a common socket. You have then sockets for the current ranges, for the voltage range on AC and the voltage range on DC. Interestingly, the current input there is also used on the ohms range. And then here you have a little sort of cutout there which you can get access to a zero preset to zero the meter to make sure you have the correct starting point. So I think the first thing we'll do is we'll switch it on. It's got its 9 volt PP3 battery installed, so we'll switch on and see how it's working. Well, we seem to be working okay. There you can see the display now flashing. Let me just see if I can get you a better view of the display. There you have a closer view of the display there. As you can see, it's 3.5 digit. You can also see have no input at the moment. I've got it set to the ×1 DC range at the moment, so let me just connect my voltage reference source. Now I've connected my 10 volts voltage reference source, and you can see there obviously it's out of range. You've got the two flashing lights there coming on, so I need to go to the ×10 range. And when I go to the ×10 range, it's reading on the meter 1.004. Obviously I need to then multiply that by 10, so it's actually 10.04 of a volt. So it's not too bad. I must admit it's a bit strange having to then do the multiplication and then interpreting the display of the voltage that you read there. Let me just go to the 5 volts reference on my unit, and the 5 volt is reading on the ×10 range 0.502. Multiply that by 10 and we've got 5.02 a volt. So it doesn't look too bad actually, to say it's been in a box for the last God knows how many years. Here you can see it with its test leads there, little spring hooks they have on the end, and this is the little instruction booklet that came with the meter at the time. Specification. And even at the back we have a circuit diagram. This is the full page advert that Sinclair put out at the time. Notice the price there is £29.95 plus 8% tax, that's VAT. You could also buy this AC adapter unit at the time from Sinclair, which meant you could use the meter permanently just plugged into the main supply. Right, well, let's see if we can take the meter apart. Turn it around. The battery compartments there, just like that's one of the things I found with this meter at the time. The battery compartment cover wasn't very good. It just used to slide off, so I used to have to stick it down with some tape. Battery. So there's the battery compartment there. There's the on-off switch, and down there is the little jack socket for the AC adapter input. There's some foam down there, but I think it's starting to perish now. It's been in a box for years. So let's see if we can get this back cover off, and if I remember correctly, you have to slide the cover forward and then pull up, I think. There we are. So that's the bottom part of the case off. There we can see inside. Interesting. It's one printed circuit board. Looks like we have some fixing clips there, and the soldering is not too bad, but they've obviously not bothered to clean up any of the flux on the board there. So let's see if we can remove the board. I think to remove it we would have to take up these tabs. Little plastic spigots there. There you go. Now the other thing I need to do is unsolder these 4 connections here that go into the input sockets. So let me just unsolder those, and then we'll come back and see if we can remove the board. Right, there I've now just unsoldered the 4 input socket connections there, but I think I may have to just take the knob off the slider switch there. I think that must just pull off, I think. Okay. Well, we should now be able to pull the board out, I think. Okay. The on-off switch appears to be, that's not so bad. That's interesting. The casing here, it looks like it was a casing for a calculator. So I would imagine that Mr. Sinclair was using the same case for a number of his products. This one is a calculator case. You can see there where the slots are, and he's then just simply cut out the calculator button slots there in the middle for the slider control. Well, this is the main board here, and it's got 1, 2, 3, 4 ICs on there, and this is the display, the range switch, and it's got a thin film resistor. Let me just move the position of this. Right, I'll just zoom into the board and see if we can get a better look at the printed circuit board and the components. Here we can see a closer look at what's on the board here. Look at the ICs, 4 ICs. There's an op amp. There we have an LM3900, which is a quad op amplifier. This chip here looks like it's the main chip on the board. The one that they've got in this one is Plessey MP3202, but that is actually a replacement to what was originally installed in these meters. The original chip that was in there was a General Instrument IC, which was the AY-5-3507 chip, and that particular IC, not only is it driving the LED display, it's also providing a lot of functionality for the 3.5 digit multimeter, and includes things like the automatic polarity detection, the overrange indication circuitry. Of course it has the drivers in for the LED display. It also contains the circuitry for the voltmeter, utilizing a dual ramp integration circuitry in there. So there's lots of things in there that is designed specifically for anybody that wanted to build at that time a 3.5 digit multimeter. And the rest of the components, just discrete components, a number of presets. You have a few 1, 2, 3, 4 transistors there. At the side of the slider switch here we have a thin film resistor network, and that is the resistor divider network on the input ranges that's used there. That preset you can see there is actually the 0 preset, which you access from the top of the meter through the hole to 0 the meter. Down here you have another IC, which is an RCA IC CD4007AE, and that is a CMOS dual complementary pair of inverters. That's made up of both P-channel and N-channel MOSFETs inside that chip, and there's a whole there's a group of them that you can just tap off. So they're using obviously the MOSFETs for the high impedance requirements there. There's a couple more transistors. If we just have a look behind the display, if I can lift it up. There we can see there's 4 transistors there. They're driving, we're using 4 of the LED displays, so there's 1 transistor for each LED display unit there, and there's another transistor down there. Now the interesting thing is with the display is that although we appear to have a number of elements to that, the number of segments there, there's only 4 that are being used. There's the magnifiers there. I'll see if I can get a closer view of that. Right, there you have a closer view of the display, and you can clearly see that there's only 4 there that are used. The others are just empty. Here we have a closer look at the divider resistor network there, the thin film resistor network, which is used on the switch range switching of the meter. And there's a diode there obviously for input protection as well, and another resistor there is used on the switching, the range switching. We can just see down there, just tilted the board, we've got a 5.2 volt Zener diode there, and we've got another Zener diode here, a 5.6 volt Zener diode. That may be something to do with the reference voltage source for the multimeter. Here we have the data sheet for that particular chip I was talking about. So the one in the meter I have here at the moment is a Plessey version, but it's the same as this one, which is a General Instrument chip, and that's the number there, the AY-5-3507. And it was designed at the time specifically for 3.5 digit multimeters. There's the block diagram of the logic circuitry inside that particular chip. Here we see an application circuit using that particular chip to control the 3.5 digit multimeter. That's the IC there in question. There's the display. They're driving the display with the digit drivers there. The there'll be transistors, so there'll be 4 transistors there, and then the segments of the display going directly from the chip here to the display. This particular IC is clocked by a 10 kilohertz oscillator, and the input is coming into that from the logic input circuitry of the digital meter there, and the reference source and the signal source is controlled also by this particular chip. And in fact this block diagram represents quite closely what Sinclair did when their engineers designed this multimeter. So let's have a quick look at the circuit that Sinclair put together for this digital multimeter. Right, here we have the circuit for the meter. I'll just quickly go through the main points. There you have the input resistor divider network there with the input range switching arrangement, and the little slider switch there going between ohms and the current and voltage range switch. There you have the input socket, so you have the DC, AC, the ohms and the current socket and the common ground. And the signal is then fed to one of the inputs of this amplifier here, and the other input is fed with a reference signal. The output from the op-amp, then the signal from there is fed into the main digital multimeter chip here, which then processes that information, digitizes it and feeds it out to the LED display. The display is controlled by that IC as well, so the IC is controlling both the segments of the LED display, and also each of the digits is controlled by one of these transistors here. There's a multiplexing, and those transistors are themselves controlled by that chip. Now this particular IC is clocked by this little multi-vibrator circuit here, which is oscillating at a frequency of around about 10 kilohertz. The voltage input to the meter is down here. Quite clearly you can see there the battery and the little jack socket for the external adapter if you're using that. This part of the circuit here is really all to do with providing a reference signal source for the digital multimeter, and again that is also controlled by that chip, so that's controlling really everything, including the reference signal, the display, and taking the input signal source for processing. This circuitry down here looks like that's to do with the ohms ranges, probably to provide some sort of a constant current source. When you're on the ohms range, that slider switch is switched over to the ohms, which is then connecting to here, to this circuitry here, and that means that circuitry is then going across the inputs as you're measuring the input resistance, or the unknown resistor that is. So that's quickly an overview of the circuit without too much detail. We haven't got a lot of information about this, and there's no component values indicated on this circuit diagram. This was the one I took from the back of the little instruction booklet that came with the meter. Well, I hope you found that little teardown of this digital multimeter of some interest. Thanks for watching, and see you all again next time. Bye for now.